Okay, so let's see a new topic, which is mixing of liquid solutions. So generally we have two types of solution, which is ideal solution and real solution. In ideal solution, when we mix V1, which is volume of solution A, and V2, which is volume of solution B, then the final solution would be V1 plus V2. But in reality, what actually happens is when we mix the two solutions, then the weight of the volume of final solution is either less than V1 plus V2 or more than V1 plus V2, depending upon the interaction between A and B's molecules. Okay, so in this case, V mix is not equal to 0 and V final is not equal to V1 plus V2. Okay, so let's say in solution A, or volume 1, we had interaction between molecules of A, and V2, and in V2 we have interaction between molecules of B and B. And if the interaction, when we mix the two mixture between A and B, is greater than interaction between A and B, then V mix is less than 0 and V final would be less than V1 plus V2. Okay, so next, that if density of final solution is not provided, assume solution to be ideal. Okay, so let's start off with a question. So if 10 grams of H2O liquid is mixed with 3.2 grams of CH3OH, density is again 0.8 gram per ml, to form a resultant solution, then what is the molarity of CH3OH in water? So these are mixed, and what is the molarity of CH3OH? Okay, so let's calculate first the number of moles of CH3OH. Okay, so number of moles of CH3OH would be fixed, that is 3.2 upon 32, which would be 0.1. Okay, and what would be the volume of resultant solution? Volume of resultant solution would be volume of HCl, or rather H2OL, plus volume of CH3OH. Okay, volume of water is directly 10 ml, plus volume of CH3OH would be 3.2 upon 0.89 or 0.8, which is the density. Okay, so this will give us volume of final solution is 14 ml. Okay, so what would be the molarity? Molarity would be 0.1 upon 14 into 1000, as the volume is in milliliters. Okay, and now this was the case 1, where the density of the final solution was not provided, hence we considered this as ideal solution, in which volume is just added as V1 plus V2. Okay, now let's see another question in which we will be dealing with real solution. So if density of the final solution is provided, then it is a real solution. Okay, so let's suppose 100 ml of H2SO4 solution having 1 m concentration and 1.5 gram per ml as the density is mixed with 400 ml H2O. Calculate the final molarity of the solution. Molarity of the solution given density of the resultant solution is 1.25 gram per ml. Okay, so 1 m concentration means 100 ml, 1000 ml solution contains 1 ml, 1 mole of H2SO4. Okay, now we have been given 100 ml solution. 100 ml solution will contain 0.1 mole of H2SO4. Okay, and now we have been given the, so from here we can calculate the mass of, so before calculating that, let's first calculate the mass of H2SO4. Okay, mass of H2SO4 would be nothing but, oh, let's calculate first mass of H2SO4 solution. Mass of H2SO4 solution would be density of H2SO4 solution into volume of solution, which is 100, so it is 150 grams. Okay, and mass of, so this is the mass of H2SO4 solution. Next what will happen is it is been added with 400 ml of water. Okay, so mass of 400 ml water would be 400 grams. Okay, so mass of the resultant solution would be, when we mix this mass would be directly added. Mass of resultant solution would be mass of H2SO4 solution plus mass of water, which is 550 grams. Hence volume of final solution would be (550 upon 1.25), which is the density in ml. Okay, now when we have to calculate the molarity of the final solution, molarity would be N of H2SO4 divided by volume of final solution resultant. Okay, so moles is 0.1, which will remain constant throughout the mixture or the mixing process, divided by 550 into 1.25 into 1000 would be the answer. Okay, so with this you can calculate this. So with this we come to an end of this lecture. In the next lecture we'll be seeing types of electrolytes.